Hello, my name is Caesar, and in this how-to, we will explore the chemical traffic light experiment, in which some simple ingredients will create a fascinating color change that looks like magic. This experiment has its roots in the blue bottle experiment, being a variation of it, but in the blue bottle experiment, instead of a blue liquid becoming clear, this one will have something a bit more interesting happening. Now, for this experiment, you will need a sodium hydroxide drawing cleaner, specifically one with light crystals. This can be picked up at any hardware store. I got mine at Home Depot, but you should be able to find it anywhere. Next, you will need some dextrose or glucose, doesn't matter which one you use, it will work the exact same for this experiment. Next, you will need indigo carbine. This is a dye. This can be essentially found at any chemical website. I was able to get mine on eBay. You should be able to find it there too. And finally, you will need some distilled water. This can be found anywhere and it must be distilled because the minerals in normal water will interfere with the experiment. Now, to start off this experiment, you add 150 ml of distilled water to a container. Once pouring the water, you can then add 3 grams of dextrose. Then, to the solution, which I will now refer to as solution A, you will add 5 grams of sodium hydroxide drain cleaner. You can now take an instrument and begin to stir it. I use a chopstick for this, but you can essentially use anything. Make sure to stir until all the ingredients are dissolved. This may take a while. As you can see, the solution, while being cloudy, has stained the chopstick yellow. This is a sign of what color the solution will be later on. Now that we're done with solution A, we can place it to the side and start making solution B. Now in solution B, we will add 100 ml of distilled water. You will now add 20 milligrams of your indigo carbine. Since most scales are unable to display measurements this small, you may need to eyeball it a little bit, but don't worry, if you add too much indigo carbine, you can always dilute it with a little more water, and if you add too little and the colors become mute, you can always add a bit more indigo carbine. You can now start to stir solution B. Now I will take out the third container. I use a flask for this, but in a pinch you should be able to use a water bottle. Just make sure to use a container that you'll be able to close the top of. You can now take solution A and start to pour it into the container. Once done, you can now take solution B and pour it into the same container. As you can see, this has started to change the color into a green. You will now take a stopper and plug the top. As you can see, the color, once being green, has started to turn to red. And now, if we leave it for a little bit, it will start to turn yellow. Now, while I wait for this chemical reaction to turn back to yellow, I will explain what's happening. The reaction in space form is the color yellow, but when shaking it, you add oxygen to the reaction. When adding oxygen, this actually changes the chemical bonds into red. This happens because the new chemical bonds reflect light a bit different, and when shaking it more, you add even more oxygen to the chemical. However, though, once leaving it to sit, the O2 will eventually diffuse back into the air, changing it back to yellow. In theory, if you shot straight O2 using a tube or something into the reaction, the color would change much quicker. And now, as you can see, the color has turned yellow. Now, I personally thought the colors weren't vivid enough for me, so I decided to add a bit more indigo carbine. But as you can see, it didn't change the solution at all, and it was perfectly fine to add. So this can show if you make a mistake, you really do not need to worry about it when adding the indigo carbine. And as you can see, taking the yellow reaction, shaking it, it becomes red. But shaking it even more, adding more O2, it slowly becomes green. The green version of this chemical requires a bit more O2 than the red one. Because of this, it will change back to red really quickly since it's a bit more stable than the green version. And the yellow version being the most stable, it will eventually turn back to yellow. But as you can see, shaking it again, adding more O2 will eventually turn it back to green, then back to red, eventually turning it back to yellow. This chemical reaction can be repeated multiple times. As you can see, I decided to take a photo of the chemical in a brighter environment to really let those colors pop and really show you just how vivid these colors are. with the yellow being a bit more amber than yellow but still being yellow.